Hi everyone, George here from Data Academy. Today we're going to talk about how to do hyperparameter tuning in Sklearn. So in Sklearn, there are two major tools that you can use to do hyperparameter tuning. One is called GridSearchCV and the other one is called Randomize the Search Cv. And today we're going to be focused on Randomize the Search Cv. Why? Because Randomize the Search Cv is actually way more efficient and actually way more feasible than GridSearchCV. Why is that? Well, this is because of the potential possible number of combinations of hyperparameters you need to search for can be really huge. And with GridSearchCV, it wouldn't be possible sometimes. So imagine if you have, for example, two hyperparameters to test for, and for each one you have two values. So then how many combinations do you need to test for in total? I would say 2 times 2, that is 4, right? However, in reality, this could be a much larger number, right? Think about it. If you have an algorithm with, let's say, 100 different hyperparameters, and for each one you have 100 different values, then how many combinations do you need to test for? It's going to be 100 times 100. That's a huge number, and it's going to take forever for you to run if your data set is relatively large. So then that's why we are going to use Randomize the Search Cv whenever possible, because this is just way more efficient. And let's take a look, how do we do this in Sklearn. So these are the same steps as before, so we're going to quickly skip these instead let's talk about how to build the model, really how to do the search here. So what we are going to do is we are going to find the best combination of the hyperparameters for the pipeline that was found by automated machine learning, and in specific Teapot, as we discussed the last time. Okay, so using Teapot last time, we were able to find a pipeline like this. Okay, so you see 3 different steps. Number 1 is the PCA for dimensionality reduction. Number 2 is the variance threshold. Number 3 is this classifier. And basically, I just copy and paste it over here. These are the 3 different steps. Now we want to do hyperparameter tuning to get the best hyperparameter configuration for this kind of pipeline. So that's the pipeline. First, we need to define, and secondly, we do need to define the hyperparameter grid. Okay, but in this case here, we would call this parameter distributions, because some of the hyperparameters, they do have a distribution instead of a simple list of different candidate values. So I'm talking about this one, for example. So this is the variance threshold, and with this hyperparameter, the distribution we're going to define is between 0 and 1, all the floats. Okay, so basically the value is going to be drawn from this distribution. So that's why we call this param distributions. But for all the other hyperparameters, they're literally just lists with different candidate values. Okay. The other thing we want to make sure that is in there is that you do need to specify the step name, so that Sklearn knows which step this specific hyperparameter is for. Okay, so in this case here, I'm saying for the PCA step, which is defined here, this is the hyperparameter, and this is the different option values. And then this is also for the PCA step, and this is the hyperparameter. These are the different values. And this is for the RF step. Okay, and this is the hyperparameter, and these are the values. And back here for the regarding the pipeline, so you basically use the pipeline class from Sklearn, and you just provide the different steps in a list, and within the list, each step is basically a tuple, including the name of the step and the object of the step. Okay, so once we defined both the pipeline and the parameter distribution, then we can go ahead and do the randomize the search CV like this. So basically you say the estimator is basically the pipeline we defined above, and the parameter distribution is the given parameter distribution. And what's important here is you need to specify the n iter, which is the number of iterations. So this is basically the number of different hyperparameter combinations you want to test for. So in this case here, I'm saying 200, but you can do 100 or 300. The idea would be the more the better. However, normally 100, 200 should be enough, because the idea would be if you randomly search through the hyperparameter space, if you do around 100, you can get, if not the best, but must be very close to the best possible configuration there. Okay, so then that's it. If we run this, we can see this is the result. And what's to notice here is that you see NaN. Basically, this means this specific hyperparameter combination, it errors out. The fitting didn't really work, and as a result, you don't have the accuracy result in here. Okay, and also you can check the best parameters by doing this, and you can look at all the cross-validation results by doing this. But this is not very nice to look at. Instead, what you can do is you can convert this to a data frame. And once you do, you are going to be able to look at all the results like this very nicely. This includes the efficiency information, and also the accuracy information, and the hyperparameter configuration. Okay, so finally, we're going to do a tenfold cross-validation on all our data on this best model as well. And what is the best model? We can get the best model like this, and this is the best model that we have, and we can do the tenfold cross-validation as we did before. And at the end, we can see we get this result. And recall that last time we were able to get this result with Teapot without doing anything. So that means basically by doing hyperparameter tuning, we were able to get a 1 percentage point improvement in terms of the accuracy. So this is not bad at all, because the state-of-the-art tenfold cross-validation accuracy is just between 94% to 98%, something like that. So this is a very good. And that's it for today. Thank you for watching. I'll see you soon.